Hi, my name is Stéphane Farou, and this is the second installment in my video overview of my book, Getting the Message Across: How to Use Presentation Software such as PowerPoint to Give Interesting Technical Presentations. Chapter 2 is about how to organize and give rhythm to a presentation, and is entitled The Score. Many presentation authors insist, rightly, on storytelling, but it's often hard to build a technical presentation like a Hollywood script. This is why I prefer talking about orchestration, with multiple stories providing a melody rather than having a single story as backbone. What is important in visual music is the combination of predictable patterns with surprises that awaken your audience when needed. A subtle combination of continuity and breaks. I'm going to illustrate it with a simple example, the intercept theorem. This is typically the kind of slide that a math instructor could use. Not bad, everything important is in it, and yet, if read during a class, unlikely to do much of an impression. I'm going to build a whole sequence of slides around it, playing on continuity and breaks to make the lesson more interesting. I'm first going to duplicate the slide and keep the hypothesis that sets the stage, but remove the theorem itself. Moreover, I'm going to animate the schema so as to be able to build it click by click when giving the hypothesis. The original slide will only be shown next and wiped from left. I talk more about slide transitions and animations in later chapters, but in many cases you can use them indifferently. As the only new element in the slide is the theorem itself, only it will move on screen. That's an improvement, but it's still dry. I need a story, and my story is that the Greek philosopher Thales is said to have used this method to compute the height of Egyptian pyramids, comparing the shadow of a stick to the shadow of the pyramid. I'm going to add a new slide, and first I need to indicate continuity, because I'm not switching to a new topic. I'm going to repeat the theorem at the same place as before, and replace the schema with a diagram that I'll also display bit by bit, showing a pyramid. To improve continuity, I have also placed the diagram in such a way that the tip of the pyramid matches the previous location of one of the angles of the triangle. The pyramid isn't the triangle, but this tip is the common element between the two successive slides and a focal point. I have worked on continuity so far, but I want this example to be the high point of all this sequence, and I want to make sure that everybody in the audience follows. To call for the attention of the easily distracted, I'm going to have the visual equivalent of a drum roll as a picture that breaks with what came before it, but announces my example. However, and this is where it becomes subtle, I still want continuity. I have reframed the picture so as to have the tip of one of the pyramids placed at the same focal point that I have previously identified. And I've added the text of the theorem because that's still the subject. Now, let's see what it gives. First, the hypothesis, then the diagram, triangle first, parallel line second. I click to wipe what was the original slide, and the theorem appears. Then, drum roll, with a carefully placed pyramid. That should surprise my audience, and I can start talking about Thales. Then the diagram, illustrating the question I want to answer. Then the sun ray, the stick, and the identification of the various points as given in the theorem. I only need to provide numerical values to involve my audience, and this should hopefully make for a more interesting and memorable lesson.